Hello guys, welcome back to Smart Interviews YouTube channel. I am 𝗟𝗲𝗃𝗃. Today we are going to see problems from CodeChef Starters 183. Let's start. Let's start with the first problem. So here the problem says that your favorite cricketer played very well. Okay. So he made some X score, X runs, exactly from 100 balls. Each ball he scored, he either scored 0, 1, 2, 3, 4 or 6 runs. Unfortunately, you missed the match. So now you are wondering what is the maximum number of sixes he could have hit. Okay, a sixer, we all know what is a sixer. In the input, you are given X, the total number of runs your player made. In the output, you need to print the maximum number of sixes possible. For example, if my X is equal to 100, we know that X 100 at max is sixes can be like, how can you get at max sixes from 100? Simply divide by 6, and we all know that it will be 16 point some value. So he could have scored 1. He could have scored 16 sixes, followed by he could have scored 1 4. So 16 into 6, 36. It will be 96, plus it may be 1 4, or it can be any other value. So we are not particular about that. We are only focused on how many sixes he has hit. So at max he can hit 96. Why? Because if we place one more 6, it will be exceeding our X value. So the expected answer is very simple. Whatever the X value is, divide by 6. Let's see the code. So here in the input we are given only X. So before we take X, let's declare the scanner. So here I can directly print the answer, like I don't even need to store in a variable. Whatever is my input, divide by 6 will be my output. Let's see. Exactly. Yeah. Let's move to the second problem. The second problem says that you are having n sticks. N sticks means the length sticks are from 1, 2, 3 and so on till n length. So that means if you are given n equal to 3, you are having 1, 2, 3. These are the lengths of the stick. Can you make a non-degenerate triangle with some 3 sticks out of n? That means if you are having, let's say, n equal to 5, that means 1, 2, 3, 4 and 5. They want to make a triangle ABC such that it is non-degenerate. So basically non-degenerate means triangle whose area is greater than 0. So they have also mentioned what is non-degenerate. If you can say like non-degenerate, in the other words, like if sum of two sides should be greater than the third side. So a plus b plus c, a plus b greater than c, b plus c greater than a, c plus a greater than b. So if your triangle is satisfying these three conditions, it means that it is a non-degenerate triangle. And they're asking you to, if it is possible to generate a triangle, they're asking you to find the maximum possible perimeter of a triangle. So perimeter is nothing but sum of three sides, a plus b plus c. And yeah, if it is not possible, they're asking you to print -1. If you come to the examples, so in the examples, you can see 4. 4 means 1, 2, 3 and 4. So out of these four numbers, you can pick 2, 3, and 4 to form a triangle. And if you see 2 plus 3 is greater than 4, 3 plus 2 is greater than, okay, my bad. 2 plus 4 is greater than 3, followed by 3 plus 4 is obviously greater than 2. So hence, it is a maximum possible triangle, which is a non-degenerate. If you pick any other combination, let's say for example 1, 2, and 4, this case fails. 1 plus 2 is definitely not greater than 4. And if you pick 1, 2, and 3, obviously 1 plus 2 is not greater than 3. It is equal to 3 but not greater than. And yeah, any other possible example fails here. Hence, we pick a 2, 3, and 4, and the perimeter comes out to be is 9. If you come to 3, it means 1, 2, 3, right? We have already seen the example where it is failing. So hence, we cannot form a triangle. We print -1. So, you must have observed, right? To pick a triangle, we need to follow these, to form a triangle, non-degenerate triangle, we need to form this kind of equations. So obviously, if any value which is greater than 3 can form a non-degenerate triangle, and moreover, if you want to get the maximum perimeter, you can simply choose the maximum, let's say n equal to 5. 1, 2, 3, 4, and 5. To get the maximum perimeter of a triangle, which is a non-degenerate triangle, you should be picking n minus 1 and n minus 2. In the case of 6, n equal to 6, you will have 1, 2, 3, 4, 5, and 6. You will be picking 4, 5, and 6. And you can just check. This follows the properties of non-degenerate. So the logic is simple. The logic is very simple. You should be picking like if n is greater than 3, the answer will be n plus 1, n minus n plus n minus 1 plus n minus 2. Else it will be -1. Okay, so let's go through the code once. So here, let me just zoom in. So yeah, let's declare the sc class, sc variable, and let's read the number of test cases sc dot next int, followed by I will be reading the only input, which is nothing but n. Next, now according to my logic, if my n is greater than 3, I will simply update my answer. So for this, I will create an answer variable. Int answer is initially -1. So answer equal to n plus n minus 1 plus n minus 3. So we can write in this way, or we can rewrite it as 3 into n minus 3. And at the end, I will print my answer. I don't need to write here else, right? Why? Because by default, my answer is already -1. Okay. Let's just see if our code works. Okay. So our code works successfully. Okay, let's see the third problem. In the third problem, you are given an array of size n positive integers. It contains only positive integers. And integer x is said to be good. Okay, so they are asking about some integer x is said to be good if there exists indices I and j such that they should be like a of I should be less than x and a of j should be greater than x. So basically what they're saying is there should be some x variable in which there should be some a of I which should be less than x and a of j which should be greater than x. So there should be some two elements which is less than and greater than x. So you need to find the you need to find the number of good integers. So you need to find all the possible values of x, and it can prove that answer is always finite. So when they say finite, you need to definitely check the constraints. If you see the constraints, this a of I always lies between the range from 1 to 100. That means, can I say the possible range for my x can be like from 1 to 100? So yeah, by default, you can assume that 1 and 100 won't be the value of x anyhow. But our output, at max our output can be 98. If you are having all the numbers from 1 to so on till 100, in that case our output will be 98. So what can I say? For this, the brute force approach can be like, so iterate for all the possibilities of x. So int x equal to from 1 going till some 100. Every time check. You can check like, search if you're having, let's say I'm iterating from 1. Okay, obviously there is no need to start from 1. You can directly start from 2. You can go only till 99. So start from 2 and check. 2, do you have, let's say for example, in this array, your x is iterating from 2 to 99. Check. Do you have 1 in the array? Yes. Do you have one element less than 2? So yeah. Do you have greater than 2 element? Yes, we have 3. So obviously 2 is one of the valid answers from this 4. Next, if I now my x will go from 2 to 3. In 3, do you have less than 3 element? Yes, you have 2 and 1. And do you have greater than 3 element? Yes, you have 6. So 3 is also possible value. Now x will iterate on 4. Do you have less than 4 element? Yes. Do you have greater than 4? Yes. In this way 4, and similarly 5, less than 5 you can consider 1, 2, 3. Greater than 5 you have 6. So the answer will be 4. The possible answers are this. When you have the second output 3 comma 3, you can see that if my x iterates from even 2 to 99, the possible values, there won't be any possible values. Why? Because if I select 1, there is no element less than 1. So for this, 1 is not the answer. If I select 2, there is no less than 2 value. For 3, there is no less than and greater than both. And followed by 4, there is no greater than element. So in this way, there won't be any possible values. Hence, the answer will be 0. So basically, in the brute force, you can iterate from 2 to 100, and then you might need an inner loop which will iterate on the array, and it will check. Here you will check, do you find smaller and greater element than x. So if you find x, means the particular iteration of x. If you find, you can increment the count value. So you can create a global count value, initially 0, and after this outer for loop, we can simply print the count. So this can be your brute force approach. And obviously, if you start to apply this, it will take a time of x into n. The inner loop takes n iterations, outer loop x. So overall, I can say that x is anyhow at max iterating from 2 to 100, right? So I can say it like 98 into n, which is nearly big of n. So this is the case. And yeah, t into n. So this is a brute force approach. You can try this out, but we have a little bit optimized approach here. The approach goes like, do you really think we need to iterate on all the possibilities of x every time? Actually, there is no requirement for that. You can directly do it like, if you observe the example 1, in the example 1, do you really think we require 2 and 3? The answer is no. Why? Because just get the range of it. Just get the minimum element possible and maximum element possible. So the minimum element is 1, maximum element is 6. So except these two elements, I can say that remaining elements will be my answer. That means 2, 3 and 5. So I can get the value like 6 minus 1 minus 1. Since 1 and 6 can't be the answer, 6 minus 1 minus 1. I can call it as AB, B minus A minus 1. Okay. So this will be the optimization for it. Let's see the code. So let's start with some initial things. And yeah, obviously I should have pre-typed it. So for every test case, again I'll be reading only one. Okay, I will be reading an array, but ideally I don't require that array. So yeah, let's just take the size of the array as an input, followed by declaration of array. Now let's take the array elements as the input. Once you're done, we need to find the max and min, right? I can do this. I can find the max and min while taking the input itself. So I can initialize my max to like maybe 100 and minimum to 1. But I need the reverse, right? Max can be 100, minimum can be. Why? Because I'll be updating my max and min later. So when I'm updating max and min later, if I have 100 here, I will definitely not get the actual maximum. Hence, max should be 1, min should be 100. So max can be updated like math.max, comma a of I. Min will also be updated in the similar way, math.min, comma a of I. So I can simply get my answer as max minus min plus 1. Let's run our code. 6 and 1, but okay, 4 and 1. Okay, let's see. So if you see the code, I'm updating here as max minus min plus 1. So it should be minus 1 first thing. But still, let's see if our code works. 4 and minus 1. If you observe, we're getting minus 1 here. Why? Because here the max and min are both 3. So 3 minus 1 goes to minus 1. So to optimize this, so to correct this, I'll be using simple if condition. If my, I can call it as my answer, int answer, max minus min plus 1, minus 1, my bad. So if my answer is greater than or equal to 0, I can go forward with printing my answer. I can go forward printing my answer. In the other case, I can directly, okay, I can directly okay, let's just try it. I can directly print answer as 0. Why? Because we don't have any possible value, possible good value. If I run it, yeah, now we're getting the correct answer. Let's see if it gets submitted. Yeah, it got submitted successfully. Let's go for the fourth problem. So the problem name is S to D. So in this we are given two binary strings S and T of individual length n. So both are having of same length. So here they are mentioning like the binary strings contains only zeros and ones obviously. So they are asking you to make S equal to T using at most 3 into n such operations. Okay. So the operation is like I moving from 1 to n. If your S of I is such that if your S of I is equal to 1, you can flip S of I plus 1. That is, if let's go to example and understand. In this problem, if you observe the first test case, both are of length 4, so this is n. Then you are having two strings one by one, S and T, you can say. So in this, you can start by converting 1 to 0 here. So since this is my ith position, since it is equal to 1, one second. Since it is equal to 1 here, what I can do is simply flip this one. So if I flip it, it converts to 0, 1, 1, 1. Now in T, I have 0 over here. So what I will do is, with the help by triggering this, I will flip this one. So it converts to 0, 1, 0, 1. So in this, initially I have triggered this one, then later I have triggered the previous one to get the required output. So this is how it will work. And if you see, in the output they're given as 3 and 2. That means they're calling this index as 3. So it is a one base indexing, 1, 2, 3, 4. So hence the output will be 3 followed by 2. This is your output. Okay. Now, and yeah, I think in the output format they're asking more specific. So in the output format, if it is possible, they're asking you to print the K. Now what is K is the number of operations performed. In this, there were two operations performed. So hence 2 is printed first, followed by you need to print the operations that you have chosen. If it is not possible, simply print -1. So yeah, that's what the question says. If multiple sequences are, yeah, and the question specifically says that if multiple sequences are possible, you can print any of them. That means all will be accepted. If I come down, let's go to the other test cases also. So 2. In this, since I'm having 0 here and I can't flip any kind of 1 here. So you can't do anything in this case. You'll simply print -1. Followed by, in the third example, since you're having 1 here, you can trigger this one, you can flip this, it becomes 1 and 1. So in this, only one step is required and you're triggering the first character, so 1. In the second example, in the fourth example, you can clearly see that both the strings are same, so 0 operations are required. You're not printing anything after that. So you must have made one observation, right? If you want to flip your S of, if your S of I, if it is not equal to if it is not equal to T of I, in this case, what you can do is, you should just simply have, what you can do here is, you should just simply have your S of I minus 1 should be 1. But in most of the cases, it can't happen. For example, if you're having a string like 0, 0, 1, 0, 0, this is your S. And your T is like 0, 1, 0, 1. So now here you don't have the previous one, right? You don't have the previous one in S. So what you will be doing is you will first trigger this one. I can say 2. So 0, 1, 1, 0. Next I will trigger this one. Why? Because you can go in the two way, right? You're flipping. So I will trigger this one. 3. It becomes 0, 1, 1, 1. At the end, I will trigger again this one. 2. So in this way you can make S equal to T. So yeah, it becomes tricky here to understand. But the idea can be like, since they have mentioned one particular point and at most 3 into n such iterations, they didn't mention minimum possible minimum possible operations. They have mentioned at most. So you can use this flipping a little bit in a different way. If you're having string, let's say 0, 1, 1 and 0, 0, 1. Okay, let's take a bigger string. It's my custom example. 1, 0, 0, 1, 0. This is my S. And if my T is like 0, 1, 0, 0, 0, 1, 0, 0, 0. Okay, I have taken a little bit bigger example. Let's take a smaller one. Yeah. So let's see if we can make this on, if I can make S equal to T or not. So in this case, what I can do is, first step, I can convert entire S string to all ones, but except the starting 0. Why? Because if I have 1, 1 here, I can convert the entire remaining string to 1. So that will be my first step. So step 1, convert all, okay, convert S to all possible ones. So I can rewrite the S as, first I will trigger this. So first I will trigger this. It becomes 0, 0, 1, 1, 1, 1, 0. Then I will trigger this position. So in the step 2 it becomes 0, 1, 1, 1, 1, 1. Now here I have triggered 3. 1, 2, 3, 4, 5 and 6. So the two operations which I have done are 3 and 5. Now I need to convert this to T. To convert this string to T, I need to see at which positions I have different things. So ideally you can see I have 0 here, I have 1 here. 0, 1, 0, 1. Now I need to flip this once such that I have 0 here. So I can use its previous position. So if I trigger this, my next string will be, so what I am triggering here, I am triggering 1, or I am triggering 2. 0, 1, 0, 1, 1, 1. Next, okay, should I be triggering 2 here? Because if you see, if I trigger 2, I can't make this one as 0. Why? Because I want a 0 here. So hence, I will start triggering from the end. So first, I will trigger this position. So it is like 1, 2, 3, 4, 5, 6. So I am going to trigger 4, 0, 1, 1, 1, 0, 1. Next, I will trigger 3. So 0, 1, 1, 0, 0, 1. At last, I will trigger 2 now. 0, 1, 0, 0, 0, 1. So now we have made the S equal to T in the 5 steps. And the order is 3, 5, 4, 3, 2. Now this might be looking complicated, but you are following ideally 2 steps. Converting S to all possible ones. You can do only this once you find the first one. And second step is compare S and T. So wherever you have zeros, just compare and flip it. So this is the approach. But with this, can you always convert S to T? The answer is no. For the following examples, like if my S and T are like 1001 and 0111, if you observe, since I'm having T here, I can't flip this 1 to 0. Hence, in this case, the output should be -1. We can also consider some other examples, like if my S is like 0011, 0111. In this example also, it is not possible. So you need to print -1. So such kind of cases, what do you observe? Till we get the first one, instead of 1, if you have 1 here, it was a not, it was some other answer. So hence, till you find the first one in both the strings, they should be same. Till you find the first one in both the strings. In this, you're finding, like, okay, at any point, if S and T characters get different, for that you'll print -1. And in this, the first character is only different, you'll print -1. Whereas if you go to the other strings, so it is not getting minus it. Till here it is same, so it is a possible some answer. You can also check for the other strings. So this will be a edge case, and this will be a main logic. So yeah, I've written this line. Let's see the number of test cases. Before that, let's just zoom in. So I'll be using TC variable here. Why? Because we have a T variable already been used. So I'll be reading. Yeah, I think in the input you're given string. You're given string length n, followed by, now you're taking string s. So instead of string, I will take character array here. So character array s. So yeah, sc dot next dot to char array. So the similar thing I'll be doing for T. The similar thing I will do for T. Followed by, now first I will handle the edge cases. For that I need a variable first. So till I find the first character, I will iterate on the both the strings. Initially I will assume my first is -1, followed by I will start iterate on strings. Now if my s of I, if it is different from my t of I can assume, like, for this there is no possible conversion from s to t. So I can simply print -1 and I can break the loop. There can be one more possibility. Else if is my s of I, if it is 1. So from here, the different kinds of possibility open. So what I will do is I will initialize my first. And I will break it. In these two cases, I will break it. Otherwise, I will just continue if both s and t are same. And yeah, I need to handle a case here, right? Like if my first if my first is still -1, what I can say is, okay, I need to initialize here to I. If my first is still -1, what does it mean is both the strings are same. That means s is equal to t. If s is equal to t, we can simply print 0. So I'll print 0 and I will continue. Why? Because I don't want this thing to again continue my remaining logic. Hence, I will keep a continue over here. Followed by, now I will start my main logic. So to store the operations, I need a list. I will use a array list here of type integer. So let's say these are going to store my operations. Array list, yeah. And then let me just zoom out. And then my remaining things that I should be doing is, so now I should convert my S to all possible ones from the first one. For that, I can use a for loop starting from, I can start from first plus 1. Why? Because first is already 1, so I can directly start from first plus 1 and go till the last index. Followed by if at any point my S is equal to 0, okay, if my S is equal to the 0th character, I can simply trigger the previous index. Once I trigger it, I can simply make S of I to 1. And the other possible case will be if my S of I is equal to 1, it is fine. Nothing to worry about it. And this is my first step. In the second step, I need to convert all possible I need to compare S and T, right? And I hope you remember we'll be comparing from the end. So int, I can start it like my I going from n-1 and starting from, and yeah, it can go till first plus 1. I can equal to also, yeah, and decrement every time. If my S of I is not equal to T of at any point, I can, the first thing I will be doing is, okay, first thing, this is not AL, OPR. First thing I will do is, I will add the operation. Since I will be triggering I-1, add I-1, and I can make S of I-1 to 0. So that will be the thing. Even if you don't write this step, it won't affect our answer. Why? Because all the operations are stored here. So we have successfully converted S to T. Now we need to print the answer. So first thing, print the number of operations. For that, I can just simply print OPR size. Next, I need to print the operations. For this, I will use this for each loop. For I in OPR, I can simply print like I with a space, and after the for loop, I can simply print a new line. Let's see if our code works. So yeah, if you observe, our code is giving a value like previous index, right? And I hope you all remember it's a 1 based indexing. So I plus 1. I hope now it should pass. So 2 3's. So first test case has the expected output -1, but we are getting x unexpected 0 here. Let's debug our code. If you just check, we are missing a crucial test case. If you just check, we are missing one crucial test case. What if this condition is triggered, s is not equal to t? What's going to happen is it breaks and still my first is -1, right? It will also print 0 here. So I don't want this to happen. I will simply do it like, I will make my first to some other value. I hope you have understood the flow. If my first is -1, if at any point it is not equal, I'm printing -1 and I'm breaking, but still my first is going to be -1, right? It will also print the 0. Hence, I will make my first to 2, and yeah, I can simply do first if it is equal to -2. I'll just continue. And I can improvise it, like I can bring this -1 down. I will do the printing things at a time. Since it follows this condition, I'll print this over here. Let's see. Now I hope there should be no more things to go. Yeah, now our code runs expected. Let's submit it. Okay. Let's see the so I hope the first case is no way going wrong, but yeah, I think we are going wrong here. Since we are checking s of I and t of I, and in this I'm updating my s of I minus 1, right? So this shouldn't be happening here. Let's just remove it, and now let's test our code. Okay, runs expected. Okay, so yeah, that's it. That's it for this video. So if you like the content, make sure to like, share and subscribe. If you want to learn coding in detail, you can join Smart Interviews Smart Coder course. And yeah, we'll meet in our next video. Bye.